Okay, hi. So I'm Izzy and I work as a media artist and game developer in Berlin. And today I'm excited to present on how I used a playful approach to build my own Lofi AR applications. And I'll also give you some ideas and how you can get started to build your own. So augmented reality, often abbreviated as AR, alters a user's perception of reality. In the example, I used a rubber duck, and you can see that it's pixelated right there. Compared to AR, virtual reality replaces one's perception completely with a digital environment. Current understandings of both forms are mostly visual. So on the left, you can see a very common VR headset called the HTC Vive. And its functionality relies on able-bodied human perception, and that's binocular perception. Inside the headset, one finds two lenses with which a human user looks at two images seen from slightly different angles. The images are displayed on an internal screen. The human brain turns these two 2D images into a 3D world. The headset on the right works similarly, but it is way cheaper. So this would be like $900 and this would be like $20. And the reason for that is that here we don't use an internal screen, but can use a smartphone and put it into the headset. And that comes with certain limitations because smartphones in general are a bit less powerful than huge VR-capable Windows PCs, but it also comes with many possibilities. So what happens, however, if binocular human vision isn't the limit for our tech? Different animals perceive their surroundings in different ways. Other mammals, like cats and rabbits, but also most birds and fish, have partly binocular and partly monocular vision. Some birds can additionally see UV light, and insects have compound eyes, whereas spiders have up to 8 eyes. Bats, however, don't rely much on vision at all and use echolocation, and sharks detect their prey with electrical perception. So with my collaborator Jasper, I've developed 10 experiments to open augmented reality up to multi-species perceptions. Jasper, if you'd be so kind to make a bird noise so people know who you are. Good. Shy bird. So we started our AR experiments with research about animal perception. In the experiment that I show you today, we have asked ourselves what happens when eyes become detached from the head and how human testers react to multi-eye vision. On the next slide, I show you a spider. So if you don't like spiders, you can just maybe briefly close your eyes. It's a cute spider. Okay, so jumping spiders of the family Philippus regius can see sharp in the range of 30 centimeters. On the picture, you can see my jumping spider, Cyan, and with her 8 eyes, she is an expert when it comes to multi-eye perception. So to simulate a multi-eye vision, my first idea was to use multiple webcams and the game engine Unity. At that point, Jasper and I worked with the HTC Vive that I've showed you before. The problems began when we tried to handle the input of multiple cameras via multiple USB slots on a Windows PC. When it finally kind of worked by using one USB port per camera, we attached the cameras to my wrists and knees and arranged the video streams in my field of vision. And this was already exciting, but the cables and the headset, they really limited my movements and I couldn't really explore my new set of detached eyes. So we wondered how to read the video streams from the cameras without being tied to a heavy computer. Our idea was to use one of the lightest computers that we can afford, the Raspberry Pi. Since people build home surveillance systems with Raspberry Pis, it is relatively easy to find examples for fetching camera output. When you use a Raspberry Pi camera board module, there's great documentation online on how to stream, modify, and analyze videos with Python and OpenCV. For my purposes of just streaming a video, I chose a tool called Motion. Motion can stream videos and also trigger scripts depending on changes in the video footage. So here you can see how it works. I used a router to locally stream the videos to a website. And up there, I just defined the stream port. And with only HTML and CSS, Jasper arranged the videos and used blend modes for overlapping effects. So that's both. To attach Raspberry Pis and webcams to the human body, we built a Lofi AR suit. So the Raspberry Pis and power banks are sewn into the suit, and 2 webcams can be used for the upper half of the body and 2 for the lower half. And I show you a video on how that looks like. And in the beginning, it also contains the spiders, but I can show you or tell you when it's gone. So it comes up now. So the recording is from a performance that we did with the suit at a local media arts festival in Kassel. And there I am performing with the suit. And in my headset, I can see the same footage as people could see in the exhibition on a monitor. So they could watch themselves being seen by the different cameras. And I can only use the suit for about half an hour because even using it for that little time feels like swimming for 2 hours. So it's apparently hard work for the brain to process for videos that are connected to one's body. Ah, yeah, the people and children did not like that installation. Yes. Yeah, so a spider was also in the exhibition in a terrarium. So coming back to the initial research questions, this experiment indicates that a different configuration of visual inputs does translate into a different sense of space and leads to adapted movements. So if you actively want to use your knees as visual inputs, moving the body to the ground starts feeling quite natural. So why Lofi AR? Why would you get started? I hope that AR isn't finally defined as a specific technology with specific tools yet, and that there's lots of room for experimentation. Lo-fi means not only to figure things out with inexpensive technology, but also to see the value in imperfections, glitches, and the experimental. Another reason to get started is that developing lo-fi AR applications is a lot of fun, or because you like pixelated flowers. Throughout my work with AR, I've used a range of different approaches, and I show some of them. So if you want to get started, here's what you can do. With the game engine Unity, you can fetch videos and arrange the imagery in 3D. You can export for the common commercial headsets, such as HTC Vive, but also Oculus, but also export apps for mobile AR. And when using mobile AR, you can use your mobile phone's real-time camera input and apply shaders to alter it. And so in this example, the color white is completely erased from the video or from the real-time camera input and replaced with the color black. In a different experiment, I've used particle I/O and a bunch of different sensors to measure air pollution. Depending on the sensor inputs, my team's app altered the mobile phone's camera imagery. On the left, you can see portable sensor packages, and on the right, the altered camera imagery. And the dark spots indicate strong carbon dioxide pollution. And we performed this as city walks in Leipzig and measured very locally, and thus made information available to citizens that's otherwise just not available. And in combination with sensors, Lo-fi AR can become also a political tool. A promising option that I haven't played much with, but that sounds also like capable of doing a lot is WebVR, and you can use, for example, the framework A-Frame, and that means you'll write your code in HTML, CSS, and use WebVR specific commands and build and animate simple 3-dimensional shapes. And the cool thing about that is that your users don't have to install anything, but they can just visit your website. So I uploaded more information on my website, and all the experiments are also available during on this domain. And yeah, I hope you feel encouraged to start something. And why not, for example, build a Lofi AR application that only relies on touch? And thanks for listening.